Namaste everybody, this is Kunal Mehta from Make Me Scientific, and today I have decided to make a video on the numericals related to echo. So first of all, you need to understand that which formula would be suitable enough to calculate the problems of the echo. I have few good problems related to echo, but first of all, we need to understand a little bit about the echo over here. In this diagram, I have shown an obstacle, say for example, a hill, and then a person is standing at some distance away from the hill, and let me call the distance between the person and the hill to be d. All right, now if this person shouts, then he's going to hear his own sound, and then the another sound will be propagated in all the directions because sound is a wave, but you need to consider that sound wave that travels towards the obstacle. So the another sound wave goes like this, and after reflection it is heard for the second time after the original sound has ceased. So that is what is the definition of an echo, is that it is the sound which is heard after the original sound has ceased, and that sound should have been reflected from any hard surface. Okay, so over here the time taken by this sound wave which is going towards the obstacle and again coming back is, say for example, t, and the sound travels d distance like this, and after reflection it travels d distance again. So the total distance, please understand, this is not displacement, total distance is d, that is equal to speed multiplied by time. As simple as that, because sound does not produce any kind of accelerated motion, so simple distance is speed into time. Now it might happen that the speed of sound will not be given in the problem. So do not assume the speed by your own. Do not take the speed of sound as 320 or 340 unless it is given to you. Correct? And it might happen that sometimes the distance and the speed would not have been given, but the time in two different situations might have been given to you. So please understand, in that situation, you will have to make two equations and eliminate any one of the variables, say for example a velocity or the distance, and then you will have to solve. So I'll give you such examples. Okay, so this is the basic formula of the echo, that is twice the distance is equal to speed into time. Now let us start with the numericals of the echo. Okay, so let us solve few questions related to echo, and the first question is, a boy hears an echo of his own from a distance, from a distant hill after 1 second. So let us make a small hill like this, and a person is, say for example, somewhere over here, and the distance from the hill, assume d. Now the moment he shouts, the sound wave goes towards the obstacle and comes back to him after the original sound has ceased, and the time taken is 1 second. The speed is given to you as 350 meters per second. Find the distance. So of course the sound has traveled twice the distance, that is equal to speed multiplied by time. So 2d, that is equal to speed, that is 350 meters per second, and the time is given as 1 second. So the second would go off and distance would be equal to 350 divided by 2. If you solve this 350 by 2, it is 175 meters. That is the answer to our problem. So the hill is at a distance of 175 meter away from the person. Okay, now let us see question number 2. A radar is able to detect the reflected wave. Okay, so the problem would be something like this. So let me draw a small radar system which uses electromagnetic waves, and you might have seen in some of the movies that it would emit electromagnetic waves like this. And say for example, if I draw a small enemy plane over here, then this electromagnetic waves travels a d distance, and then after reflection it comes back again. So the total distance again is 2d. So 2d is equal to speed into time. So here the speed is not of the sound wave. Electromagnetic waves, they travel with the speed of light. So the d would be equal to speed, that is 3 into 10 raised to 8, and the time given to us is 0.02 but milliseconds. And please understand, the speed is given in seconds, so it is multiplied by 10 raised to minus 3. You will have to apply minus the 3 seconds, and this is again meter upon second and divided by 2. Correct? So let us solve this and get the answer. So this is 3 into 0.02 into 10 raised to 8, and then this is 10 raised to 5. So divided by 2, this is 0.01. So that is equal to 0.03 into 10 raised to 5. The answer would be in meters. And if I again solve this, then this is 2 zeros gone. So this is 3 into 10 raised to 3 meters, and that can be written as 3 kilometers. So that is the answer to our problem. Now, here let's solve problem number 3. The boy is standing in front of a wall at a distance of 85 meters. So this is the wall, and a person is standing at a distance of 85 meters. It's my request to all my viewers that if you draw the diagrams, the situation would be more clear to you, and you will be able to solve the problems more quickly. It's not a mandatory thing, but if you do it, you'll be able to get an accurate answer. This is how I do, right? So the distance between the hill and the person is 85 meters, and he produces 2 claps per second. That means, say for example, at time is equal to 0, he claps, right? And then again after 0.5 seconds, he claps. So the time gap between 2 claps is 0.5 seconds, right? Because in 1 second he is producing 2 claps. Or you can understand it like this: at time is equal to 0, you start the stopwatch, one after 0.5 seconds, another after 0.5 seconds. So like that. So he notices that, okay, so suppose he claps at for the first time, correct? So he is able to hear his own sound, and the other sound travels towards the hill, right? And when he claps the second time, the reflected sound reaches his ears again, correct? So the clapping of the original sound and the reflected sound is coinciding. That is what is given in the question. So that means, what is the time taken by this entire sound wave to travel twice of 85 meters distance? 0.5 seconds. Did you understand this problem well? See, he claps for the first time. So one sound wave goes, and after reflection comes. So after a gap of 0.5 seconds, he's again clapping. So the reflected sound and this clap new sound is like together heard. So only one sound is heard, right? That is what is the question. So twice the distance, that is equal to speed into time. Distance is already given to us as 85 meters. The speed of sound we don't know. That is what is to be found out. Time is 0.5. Very trickily, they have given us the question, right? So V would be equal to, and everything is in SI unit. So 2 into 85 upon 0.5 is again 1 by 2. So I'll take it up. So 4 multiplied by 85. So it is 4 5s are 20, 0, 2, 4 8s are 32. So 340 meters per second is the answer to the problem. Okay, the fourth question. Okay, so in the diagram, suppose this is the person, and this person is at a distance of 60 meters. Correct? Now this person claps. So the time has started in the stopwatch, and the stopwatch is with this person. Let us say he has started the stopwatch at time is equal to 0, and the person has clapped. Now the second clap, the first clap's sound reflects and comes back. This person claps again. Again, that clap sound reflects and comes back. He is hearing the echo, he claps again. So he is clapping 50 times, first 50 claps in 18 seconds. So the total time is 18 seconds, and that too for 50 claps. So the time for one clap would be equal to 18 divided by 50 seconds. This is the time interval between the two claps. And the moment I clap, the sound wave goes, reflects and comes back, I clap again. Correct? So this is the time gap between the two gaps, between the two claps, and that is the time gap for the sound to be reflected and coming to your ear again. So the time taken by the sound wave to travel 2D distance, that is twice of 60 meters, is same as 18 by 50. So 2D is equal to V into T. So this is 2 into 60, and that is the speed of sound is to be found out. So the time is 18 divided by 50. So V would be equal to 2 into 60 into 50 divided by 18. So answer is 333.33 meters per second. I hope you might have understood this problem. Please understand, one time clap and the sound goes towards the hill and again comes back, he's clapping. So the time gap between two claps is 18 by 50, and that is the time in which the person hears the echo, and that is the time in which the person or the sound wave travels twice the 60 meters distance. So this is how it is done. Okay. Now a man is standing in front of a vertical cliff, fires a gun. So here he's standing and he is firing a gun. The moment he fires a gun, that means the sound will travel like this, and again it is going to get reflected and comes back, and it will come back. Correct? So he hears the echo after 3 seconds. So if I assume the distance to be d, then twice the d distance, that is equal to speed multiplied by time, and the time taken by this entire sound wave is given by 3 seconds. Now he says that the person moves closer. So he suppose now goes like this, closer by a distance of 82.5 meters. So now he fires a guns again. So now the distance would be this much. So it will be d minus 82.5 times 2. Because earlier the distance was d, now he goes 82.5 meters. So the distance between the cliff and the person, or the wall and the person, reduces. So now the new distance is d minus 82.5, and this is the distance traveled by the sound wave, twice of that. So now I will write the equation as twice of d minus 82.5, that is equal to v multiplied by time, and now the echo is heard after 2.5 seconds. So here please understand that earlier d and d, so the distance is 2d and the time was 3 seconds. Now the distance has reduced and it is d minus 82.5, and again multiplied by 2, and for this I mean the reflection of sound time is 2.5 seconds, like this. Now if I take the ratio of these two equations, v will get cancelled, then 2 will get cancelled. So let me write it again, d upon d minus 82.5, that is equal to 3 upon 2.5 can be written as 5 by 2, so it goes up like this. So d upon d minus 82.5, that is equal to 6 upon 5. Now cross multiplication. So that's what I was saying in the beginning, that if you are not given the speed, please do not assume the speed, right? We are supposed to find out the distance and speed. So make two equations, take the ratio and eliminate any one of the variable like v or d. So you can also make v as the subject and solve it. That's totally fine. Okay. So here it will be 5d, that will be equal to 6d minus 82.5. 82.5 multiplied by 6 is 495. So here d would be equal to 495 meters. That is the first answer. Now, out of any two equations, like the first equation was 2d is equal to v into 3. So I'm going to substitute here d as 495. That is equal to v into 3. So 495 multiplied by 2 is 990 divided by 3. So answer is v is equal to 330 meters per second. This is how the problems are to be done. Let's move ahead. Another good question on the echo. Now the pendulum has frequency 5 vibrations per second. That means in 1 second the pendulum oscillates 5 times. Correct? And the observer starts the pendulum and fires a gun. Then he hears the echo after 8 vibrations of the pendulum. So let me draw a cliff over here. and a person is firing a gun. He is also having a pendulum. Okay, so the moment he fires the gun, he starts swinging the pendulum. So the moment he fires, the sound goes towards the cliff and comes back. Meanwhile, the sound comes back, hears the echo. The pendulum has oscillated 8 times. Correct. So for one oscillation, right, what is the time taken? For one oscillation, time taken is 1 upon 5 seconds. Because for 5 oscillations, 1 second. So for 8 oscillations, how much time? So the time here would be 8 by 5 seconds. And in this time, he hears the echo. So when the pendulum oscillates 8 times, the sound from the gun goes towards the cliff and again reflects back. So the time taken to travel twice the distance is 8 by 5 seconds, correct? So this is distance d and again distance d. So 2d distance, if I take this distance as d, then twice the distance is equal to speed multiplied by time. Speed of sound is already given to us. So 2 into d, that is equal to 340 into 8 by 5, correct? So if I multiply 340 by 8, and then divided by 5, that is equal to 544. So 2d is equal to 544. Then again divided by 2, the answer is 272 meters. So the distance is 272 meters. I hope you might have understood this problem well. The person fires the gun and starts swinging the pendulum. So for one oscillation, the pendulum takes 1 by 5 seconds. So for 8 oscillations, 8 by 5 seconds. And meanwhile, the sound reflects and comes back. Okay. Now, the seventh problem. The man stands in front of a vertical cliff and fires a gun. Okay. He hears an echo after 2.5 seconds on moving closer again. So this question is almost a repetition of the question which I did, I think question number 3 or 4. So again, let us understand by the same way. The distance, the original distance is, say, for example, d. Correct. So the sound travels d forward and d distance backwards. So the distance is 2d, that is equal to speed of sound, we don't know, and the time taken is 2.5 seconds for this entire 2d journey. Okay, this is my equation number 1. Now, if this person moves closer by an 80 meters, say for example, now he comes here and this is 80 meters, so the distance between the person and the obstacle has decreased. So now the sound will come faster because the distance from the source, I mean the reflected the surface decreases. So now the new distance would be d minus 80 and again d minus 80 backwards. So now the new equation will be twice of d minus 80, that is equal to same speed because the speed does not change. The medium remains the same, multiplied by, now the echo is heard after 2 seconds. This is my equation number 2. I'm going to divide both of them. So v gets cancelled, 2 gets cancelled. So d upon d minus 80, that is equal to 2.5 can be written as 5 by 2, so it will become 5 by 4. Solving this equation, 4d is equal to 5d. 5 it's a 40, so it is 400. So the distance itself is 400 meters. Now, I'm going to use this distance, this is my first answer, into any one of the equations above. So that is 2d is equal to v into 2.5 is again 5 by 2. So twice of distance is 400, that I have already found out. That is speed into 5 by 2. So this becomes v is equal to 4 into 400 divided by 5. So 5 ones are 5 eights are. So 8 fours are 32. So it is 320 meters per second is the answer. Okay. So this is how the numericals are to be done. Now let us solve the last question. And I hope that these concepts might have helped you out. Okay. The person, again, a very good question. A person is standing between two parallel cliffs like this. These are the two cliffs, and the person is somewhere standing in between. That does not mean that he is exactly in between both the hills. Okay, and the distance between both the hills is 99 meters. It is given to you. Now, the person, say for example, is standing here and he fires a gun. So if he fires the gun, the sound waves will go in this direction as well as in this direction. So it will go towards hill number 1 and hill number 2. So after the original sound is ceased, the reflected sound from hill number 1 will come faster because the person is near to that hill. Correct? And let me assume this distance between the nearest hill and the person to be x. So the sound travels a distance 2x, that is equal to speed of the sound waves multiplied by time. Now he hears two echoes. Now the first one is 0.2 and the another one is 0.4 seconds. From this you should understand the person is not exactly in between, otherwise it would have taken same time. Correct? So this is 0.2. So since the hill number 1 is closer, so the sound waves reflects faster and comes back to him. So the time is 0.2 seconds. Now the other distance is 99 minus x, because the total distance is 99. So the another distance is 99 minus x. So here the sound wave would travel 99 minus x forward and again 99 minus x backward. So again twice the 99 minus x, that is equal to the same speed because the speed of sound does not change. This is 0.4 seconds. Again, I am going to give you a very short trick and you may solve just orally this question, but let us solve this first. Again, both equations, and I am dividing both the equations. So x upon 99 minus x, that is equal to multiply up and down by 10, so it becomes 2 by 4, so it is 1 by 2. Cross multiplying, 2x is equal to 99 minus x. So here 3x is equal to 99 and x is equal to 33 meters. This is the first answer. And of course, the nearest hill, since it is at a distance of 33 meter, so the comparatively the far away hill is at 66 meters. So this is how the problem can also be logically done. Suppose here the echo is heard in 0.2 seconds and here the echo is heard in double the time. So whatever the distance traveled here, right, double the distance would be traveled over here because the speed is the same. So if I assume the distance x, then here 2x, then 2x plus x is 3x, then 3x is equal to 99, x is equal to 33 meters, can directly be, we can solve it. But I think that in exam they do require justification, and this is a good way. Now let us plug in this 33 meters in the first equation. So 2x is equal to v into 0.2. So 2 into 33, that is equal to v into 0.2. So here v will be equal to 33 into 0.2, sorry, multiplied by 2 divided by 0.2. So 2 ones are 2, 0.1. So 33 by 0.1 is 330 meters per second. So I hope that this video might have helped you out. And if you have understood, please comment. And if you have any doubts, then also please leave your valuable comments in the comment section. Thank you for